Good day, guys. Welcome back to our YouTube channel. So, just like always, guys, Stifler is me, and me is Stifler, guys. So today we are on work, energy, and power. We are picking up from where we left, guys. So yeah. So last time when we met, we spoke about positive work, negative work, and then zero work. So today we are moving on with the work on work, energy, and power. So today we are more of on focusing on WorkNet or network, however that you prefer to call it. So this is where we are today, guys. So guys, so throughout we're dealing with single forces acting on an object, right, to get positive work, negative work, or zero work. But in reality, we know that a single object can be acted upon by many forces acting on it, right? So that's why we have to deal with network or WorkNet. So what is network? What is network or WorkNet? So how can we describe network or WorkNet? So WorkNet can be described in two ways that if you understand any, it's cool. So network can be described as the sum of all works done by all forces acting on a single object. So this is one of the ways we can describe network or WorkNet done. So network, we can show it by this. So this is our WorkNet, right? So this is the sum of all works done by all forces acting on a single object, right? So the way that we can show this by saying WorkNet is equals to work done by force 1 plus work done by force 2 plus work done by force 3, and so on, depending on how many forces we are having acting on a single object. So this is work done by force 1 plus work done by force 2 plus work done by force 3, and so on, right? That is one of the definitions. And another definition, you can also explain this by saying the WorkNet is the product of the FNet acting on an object and the displacement. So we can also explain this by saying WorkNet is the product of FNet acting on the object and the object's displacement. So mathematically, we can also place it like WorkNet is equals to FNet and then the displacement, right? So these are two ways that we can calculate the WorkNet, and they are both correct if they are used in a correct manner, right? So that is how we can calculate WorkNet, right? Before we go on to whatever that we want to do today, guys, don't forget what we talked about on the last session. We said direction is important, right? Direction is important. Direction of the force that is acting on an object, right? We said all forces as positive forces, right? So all the forces acting or all the forces going in the same direction as motion we are viewing them as positive forces, and all the forces going in the opposite direction. So negative forces. So once we understand that the forces going in the same direction as motion are positive, and all other forces that are going in the opposite direction, we can take them as negative, then we are good to go. But again, don't forget that if we're having a positive work, we said energy is added to the object, or this is the addition of energy to the object. And if it is negative, this is the removal of energy, or the transferring out of energy. So this is the removal of energy from the object. So this is the removal of energy from the object, or this is the transferring out of energy from the object. Having said that, we are ready now to deal with the work net. So also, before we dive in too much into this topic, this is just a heads up. So you must learn how to draw the free body diagrams, because free body diagrams are important in this topic. Like I explained at the beginning of our first session, that there's some of the topics that are so much important when we're dealing with work, energy, and power. So one of those topics are learning how to draw the free body diagrams. So I've made a video about free body diagrams. You can check on the link that is provided there, so that you can check how to draw the free body diagrams, or you can perfect your ways of drawing free body diagrams. So let's just try to calculate the work net using these examples that I'm going to give you here, so that we can work together and try to find the work net. So let's take a look at this example that I've provided there. So it says a 3 kg remote controlled car. So this is a 3 kg car that is driven up a 4-meter long plane. So this plane is close to 4 meters, right? So it is driven up a 4-meter inclined plane. And then what else are we told? That is inclined at 30 degrees. So this is inclined at 30 degrees to the horizontal. The car's motor exerts an average forward force of 40 newtons. So this means that our force applied by this car is close to 40 newtons, right? And the car experiences a frictional force of 15 newtons. So this is our frictional force of 15 newtons as it moves up the inclined plane. And then they said calculate the work net done, or the network done. So our objective here is to calculate the work net done on the car. So this is what we're trying to calculate. So just like I advised you, we must first draw the free body diagram, so that we can see which forces are acting parallel to the plane, right? So let's try to draw the free body diagram of this. So we are having our inclined plane there, and we're having the incline of 30 degrees, right? So we have our object there. So first thing first, there are two forces that you must put at first before putting anything else, which are normal force. So normal force, as we said, it is always perpendicular to the plane. And then we have Fg, gravitational force, which is always perpendicular downwards, right? Perpendicular downwards. And we have the applied force by this. So this is the force applied by the engine of this car, right? And you also have frictional force. So frictional force, as we know it, it always opposes motion, right? So now we're having a situation like this. So like I said, or like I explained on the previous session, I said, let's take the direction of motion as our positive side. So this object is going up the ramp. So this is going up the ramp. So it means that our up is positive. So it means that down the ramp, it will become our negative, right? Down the ramp, it will become our negative. And again, I explained on our last session that this normal force, it is always giving us 0 work because it is perpendicular to the motion of the object. So this one always gives us a 0 work. So now let's check which of these forces will do work. So we have force applied, which will give us positive work because it is going in the motion of the object. And we have frictional force, which will give us negative work because it is moving against the motion of the object. And now talking about this Fg now. So this gravitational force has 2 components. So this one has 2 components. We have Fg perpendicular, which is this force here, that is like this, and it is perpendicular to the plane. So this gives us 0 work. And we have another component, which is Fg parallel. So this is Fg parallel. So this, according to this, it will give us negative work. So this will give us negative work because it is acting downwards, while this object is going up the plane. So it means that this will give us the negative work. So now, according to the 2 ways that we explained, let's try to calculate the net work done on this object. So it means that first we can calculate the net work done using the first way, the first definition, and we can calculate it using the second definition, right? So on the first definition, we said work net is equals to work done by force 1 plus work done by force 2 plus work done by force 3, and so on, right? So let's calculate the work done by each and every force, right? So like I explained last time, that if we are trying to calculate the work done by each force, firstly we have to resolve them into its components if they are not into components. So it means that first thing we have to calculate the component of Fg. So this is Fg parallel. So how do you calculate Fg parallel? We say it's equals to mg and then sine of theta, theta being this angle here. So guys, if you're not familiar with this, please just go back and watch the video on forces, right? So this becomes, now what is the mass of this? This is 3, and g is always constant, which is 9.8, and then sine of 30. So after putting that in your calculator, you're going to find that this Fg is equals to 14.7 newtons. And don't forget that this is downwards. So this is acting downwards, right? So don't forget that. So now, after saying that, it means that now we are having Fg, which is acting downwards, or Fg parallel, which is acting down the slope, and we're having frictional force, which is also acting down the slope, right? So we can calculate the work done by each of those forces, right? So let's start. So what is the work done by that? So the work done by Fg will become now force of Fg, and then changing that. So I already explained that all the forces that are going down the slope, we are going to put them as negative forces. So it means that now the work done by Fg becomes 14, and don't forget to put the negative because this is a negative force, and then our displacement there, we said it is 4. So we're going to include 14.7 multiplied by 4. So this work done by FG becomes negative 58.8 joules. So this is a negative work done by the FG, like that, right? So this is the work done by the gravitational force, right? So now let's go to the work that is done by the frictional force. So let's see. So the work done by the frictional force now will be equals to the force of friction multiplied by the displacement. So this is, they said the frictional force is equals to 15 newtons, right? So we're going to place it as a negative 15 because already we explained that any forces that are going opposite to the motion, we are taking them as negative. So multiply by the displacement, which is 4 meters, and we're going to get negative 60 joules. So it means that frictional force is doing a negative work of 60 joules, right? So now let's go to the positive work that is done by the force applied by the engine, right? So work done by the force applied will be equals to the force applied multiplied by the displacement, which this is the force applied by this, it is 40 newtons. So we're just going to replace it by positive 40 because this is a positive work multiplied by 4. So this gives us a positive 160 joules. So this is a positive 160 joules done by the force applied, right? So now that we've calculated all the works done by the required forces, because this is giving us 0 work, this is giving us 0 work, so we don't consider them, and we're having this that is giving us the positive work, and we're having the frictional force that is giving us the negative work, and we also have the parallel component of Fg, which is giving us the negative work. So like we explained, we said the work net, it is the sum of all the works acting on the object. So we can say work net now becomes work done by the force of friction plus work done by the force of applied plus work done by the Fg, right? So it means that our work net now, since we're having all the works that are done by those forces, it now becomes work done by frictional force, it is negative 60 plus work done by the force applied, which is 160, and then plus the work done by the Fg, which is negative 58.8. So putting everything together now, in the calculator now, we can find that our work net is equals to the positive 41.2 joules. Positive 41.2 joules, which means that there was a positive work done, the positive work net done on the object, right? So let's look at the second way that you can use to calculate that. Okay, so let's work on the second way that we say we can use to define work net. So on the second way, we said work net. Okay, so this is the one that I prefer, guys. So it says work net is equals to the product of F net and the displacement. So it means that the first thing is calculate the F net. So let's try to calculate the F net on this, as we are told that, and we have calculated already that the Fg parallel is equals to 14.7 newtons, right, downwards. So let's try to calculate the F net. So what is the F net according to the definition? We know that F net is equals to the sum of all the forces that are acting on this. So which forces are we having now? We're having force applied minus frictional force, because frictional force is going in the opposite direction, plus negative FG parallel, which is also going in the negative direction. So our F net now becomes the force applied, which is 40 newtons, plus the frictional force, which is negative 15 newtons, and then FG parallel, which is 14.7 newtons, which is 14.7 newtons. So now we can plug in everything in the calculator and find that our F net becomes positive 10.3 newtons. So if this is our F net now, which is positive, it means that it is going in the same direction as motion. So it means that our F net is going in the same direction as motion. So it means that now we can say our work net becomes F net and then displacement, right? As easy as that. So this is positive 10.3 newton multiplied by the displacement of 4 newtons. So having said that, this will give us that our work net is positive 41.2 joules. So this is a positive work done again. So these are the two ways that we can use to calculate the work net. And as I said, this is the one that I prefer the most because it is simple to use, right? So let me just give you a simple hints on how you can use this, and then we can have another example, and then I'll give you the checkpoints, things that you can work on, and then I'll come with the solutions on the checkpoint solution video, right? So these are the tips, guys. So the first thing is to draw the free body diagram. Don't forget to show all the forces. Make sure that you are showing all the forces, right? You're showing all forces acting on this object, right? And then from then, after drawing the free body diagram, just ignore all the perpendicular forces, to the plane. So all forces that are perpendicular to the plane, ignore them. The forces like the normal force, right? And if this is an inclined plane, you must also ignore the perpendicular component of FG. But the parallel component of FG, don't ignore it, right? And then the next thing, calculate the F net. And then always keep in mind the direction, right? So we always choose the direction of motion as positive. So if our object is going up the inclined plane, or if our object is going to the right, then we are taking that direction as the positive direction, and anything else will be negative. So all the forces that are going to the plane, we'll call them, that are going to the motion of the object, they'll be positive, right? And all other forces, they'll be negative. And then after doing that, now we can calculate the work net using F net and then changing displacement. And again, if our F net is positive, then we are going to get positive work. If our F net is negative, we are going to get negative work. And we need to include that positive or negative here on the calculation, right? So these are the tips that you can use. So now let's try to deal with another example dealing with the work net, and then I will leave you with checkpoint 1, right? So now let's take a look at this example that I've shown you there. So it is saying a truck of 2000 kg. So the mass of this truck, it is 2000 kgs, right? Free wheels down a 30-meter long. So if something is freewheeling, it means that it is not applying any force. So this is not applying any force. So it means that our force applied is equals to 0 newtons. As simple as that. So this is freewheeling down a slope inclined plane of 30. So this is our angle of inclination. It is 30 degrees, right, to the horizontal. It experiences a frictional force of, so this is our frictional force, which is equals to 5,500 newtons, right, as it freewheels down the inclined plane. And then they say calculate the F net. So we're trying to calculate the F net of this object now, right? So let's try to show this diagrammatically. So this is our object there. So it is freewheeling down, experiencing a frictional force, and this is at an angle of 30 degrees, right? And then they say calculate the work net done on this object. Just like I explained on the previous example, that the first thing before anything else, it is to draw a free body diagram, right? So let's draw a free body diagram. So this is our free body diagram, and we are going to show our object there, and this is inclined at 30 degrees. So first thing, we are going to put those two forces that I said before anything else, put them. So this is normal force and Fg, right? And this is freewheeling down the slope. So if it is going down the slope, it means that our frictional force is up the slope. So frictional force always opposes motion. So this is our frictional force. But this thing is freewheeling down, so it means that there is no applied force. So like I said, our Fg in this case, it is having two components. This force now, it is having two components. So it is having the Fg perpendicular, which is perpendicular to the plane, and it is having Fg parallel. So Fg parallel always acts down the plane, right? It always acts down the plane. So taking a look at this, it means that we're having two forces that are parallel to the plane. So these are the forces that we're going to think about, or these are the forces that we're going to include, right? So first thing first, we have to calculate the component of Fg, this Fg parallel, right? So how do you calculate it? We can say Fg parallel is equals to mg and then sine of theta, right? So this becomes the mass, which is 2000 multiplied by 9.8 multiplied by the sine of 30, right? So this, our Fg parallel now becomes what? Our Fg parallel now becomes 9,800 newtons. So this is 9,800 newtons down the slope. So to calculate our work net, I said to calculate our work net, we need to calculate the F net first. So what is our F net? So this object is going down the slope, so it means that all the forces going down will be positive and the other forces going against will be negative. So our F net now becomes Fg parallel plus negative frictional force. So this is 9,800 plus negative 5,500, because they said our frictional force is 5,500 newtons. So it means that now our F net becomes positive 4,300 newtons. So it means that this F net, it is a positive F net. So this is a positive F net. So having said that, now let's calculate the work net. How do you calculate the work net? We say work net is equals to F net and then the displacement. And our displacement there, they said it is how many meters? So they said this F net, so is equals to 30 meters as well, right? So this is 30 meter long. So we are going to say our work net becomes our F net, which is positive 4,300. So this is 300 multiplied by 30 meters. So this work net of ours becomes positive 129,000 joules, which is a positive work. So you can also use that way that you talked about of first calculating the work done by each force, and still you are going to get the same answer, right? I used this way because this is the easier way, and this is the way that is easier to follow and also straightforward, and also it won't make you get confused because you're calculating F net first, and already I've given you the tips on how you can use this force. So having said that, guys, I'm going to leave you with work checkpoint 1, so you can check through this checkpoint 1, and then we can deal with it on our next session, right? So having said that, guys, so if you haven't subscribed, please subscribe, and also please share this and like, so that you can keep creating content like this, guys. So see you on the next one.